evening, students. So now we'll get started with the next exercise, 7.7. If possible, I'll teach 7.7 and 7.8 also, so that you can work out through. So 7.8 is not there. 7.7 and 7.9 I'll explain so that you can work out through the weekend. Listen. So now we have seen integral by parts, right? Now we'll be concentrating on the next topic, that is integrals of some more types, in which we will have root of x square minus a square, root of x square plus a square, and root of a square minus x square, everything in the numerator itself. Okay. So root of x square minus a square, root of x square plus a square, and root of a square minus x square. So everything is in the numerator. Now what we are going to do is, we are going to see what is the integral of all this. Right, till now we would have seen root of x square minus a square in the denominator. Now we are going to see it in the numerator. Let's see how to do this. So first one, root of x square minus a square. So whenever you have something like this, we need to put x is equal to a secant theta or a cosecant theta. Now I'll put a secant theta, which implies dx is equal to how much? A secant theta tan theta, right? So integral of root of a square into 1 minus, a square into secant square theta minus 1 into dx is a secant theta tan theta. Right, this will become integral of a square into secant theta into, this will see root of a square is a into a will give you a square. Root of secant square theta minus 1 is root of tan square theta, that is tan theta. So secant theta into tan square theta. Right? Are you able to understand what happened?
Yes, sir.
Yes, understood.
Yeah. So just a minute. So root of a into tan square. I'm just, so x is equal to a secant theta, d is equal to a secant theta tan theta. This will go slightly lengthy. So let's not go by this method. I'm sure we can do by this, but let's not go by it. We'll go with by parts. The reason why I didn't go with it is because, see, I'll tell you what was the issue I faced. A square secant square theta tan theta. Right, this is what we got. Then again, what we are supposed to do is write this tan square theta as secant square theta minus 1 and then proceed, or we have to write this as a square into secant theta tan theta into secant theta, into tan theta, something like this. Okay, I can write like, I thought of this. But if you observe, neither one of them is the derivative of the other. See, for example, if I take tan theta is equal to t, then here what should have been there? Secant square theta was there, then I would have got the answer easily. Correct? Similarly, if I take secant theta as t, then secant theta tan theta would have been easy for me to do it. So I'm neither able to do both of the steps. So I thought it is complicated, so I'm dropping this plan. But actually, you can do it. Not that you can't do it. You can. So if I take I is equal to integral of root of x square minus a square dx, then I can take this as root of x square minus a square into 1 into dx. So if I apply this isolate rule, then what is going to happen? Algebraic will be 1. Okay, I can take either of them as 1. Right? But remember, I can take either of them as 1 because 1 is also an algebraic function. Here the tricky part is, you need to know which one should be chosen as the first and which one as second. Remember, when you're doing by parts, right? It is the first function into integral of second function minus integral of derivative of first function into integral of second function, right? So first function, wherever it is there, you're going to differentiate it. And the second function is you're going to integrate it. So you logically tell me which one should I take first so that you're able to proceed better. Should I take root of x square minus a square as 1 or 1 itself as 1?
1 itself as 1, sir.
If you take 1 itself as 1, in this process, what will happen? Derivative of first function, derivative of 1 will give you 0. Then this is of no use for you to do by parts. So what you will do is you will take 1 as the second function. Okay.
Okay.
This is first, this is second. So I will be equal to first function into integral of second function minus integral of derivative of first function 1 by root of x square minus a square into 2x. Right? 1 by 2 root of x square minus a square into 2x into integral of 1 dx, that is x dx. So 2 and 2 will get cancelled. I will be equal to root of x square minus a square with an x minus integral of, this becomes x square, no, integral of x square. I'll add and subtract a square divided by root of x square minus a square dx, because that is the logic when the numerator and the denominator have the same power terms. Right. So I will be equal to x into root of x square minus a square minus, this will become what? Yeah. So this will become integral of root of x square minus a square minus integral of a square by root of x square minus a square dx. Just check this step. If there is any doubt, get it clarified. So here it is root of x square minus a square dx.
So I didn't understand how we got root of x square minus a square dx, the middle term.
It is simple. If you take this x square minus a square by root of x square minus a square plus a square divided by root of x square minus a square. Now it makes sense. X square
Now
minus
it
a
makes
square.
sense. I understood.
Yeah, x divided by root x. This will become root x. So root of x square minus a square dx. Now it's fine. Yeah. Now listen to this. What is this thing? Root of x square minus a square is a question. So the question itself, you called it as I. So can I write this as I?
Yes,
so that
sir.
I'll bring this I to the side. It becomes 2i is equal to x into root of x square minus a square minus a square into integral of dx divided by root of x square minus a square. Okay. So I will be equal to x by 2 into root of x square minus a square minus a square by 2 into dx by root of x square minus a square will give us, there is a formula, log of x plus root of x square minus a square plus c. So this whole thing is the formula. I'm sorry I had to write on top of letters, but I'm assuming that you would have understood this step. That is, I took this a square outside. Dx by root of x square minus a square has a ready-made formula. What is it? Log of x plus root of x square minus a square plus c, right? So this is what is going to be the formula, and you are expected this to be remembered because in the next chapter, you need to find the area under a circle and all those things. There's actually an area under a circle. Okay, so you have to apply this formula and then apply the limits. Better you memorize it. As I mentioned in the previous part itself, ensure that you have the formula sheet for every small formula that is there in this chapter. You guys maintain it separately. Done?
Yes, sir. Done.
Okay. So using the same logic, will you be able to derive, Rohan, will you be able to help me? Derive root of x square minus a square, root of x square plus a square formula. So that's the next one, right? So I take this as I
Yes,
tell
sir,
me
that's the next
how.
one.
So into 1 dx.
Take root of x square plus a square as the first function and 1 as the second function.
Very good. I is equal to
Then we do use the UDV formula.
what is it? First function into
Integral
of
of the
second function,
second
that is
function
x.
minus integral of integral of the integral of second function to derivative of first function.
Yeah, that's right. Integral of what is the derivative of the first function? 1 by
2 root of x square plus a square.
Is that all?
Into x.
Into 2x. Into integral of 1 dx is going to be x and you have a dx. So 2 and 2 will get cancelled. I will be equal to root of x square plus a square, the whole thing multiplied with x, minus integral of x square divided by root of x square plus a square dx. Correct? Now what are we supposed to do? I'll say one step. X square is already there. So what am I supposed to do to match to the denominator?
Add and subtract a square.
So if I add and subtract a square, then I will be equal to x into root of x square plus a square. Be careful with this minus integral of x
Root
square
over
plus
x
a
square
square.
plus a square.
Yeah. Then
minus integral of a square by root over x square plus a square.
you made a mistake. Check. I told you to be careful with it.
It should be plus at the end.
This minus will get multiplied with this minus. No, it is plus. The whole game will change. So this will cancel this root times. And this is what? This whole thing will become I. And I will bring it to this side. It becomes 2i. 2i into root x. 2i is equal to x into root of x square plus a square plus a square into integral of dx divided by root of x square plus a square. So I will be equal to x by 2 into root of x square plus a square plus a square into, there is a ready-made formula. What is it?
Yes, a log into x plus root over x square plus square.
That's it. Right? Is it simple? So I suggest everybody to copy it fast. 1 minute. Okay, 1 minute. There's a square by 2. Right here also I wrote no a square by 2. Now, last root of a square minus x square. So here what is going to happen is same logic you can use, right?
Yes, sir.
Rohan, tell me. There's 1, this is 2. So
Yes, so
this I
I'll
will
get
take
root over a square minus x square into x.
Okay, minus integral of derivative of it 1 by 2 root of a square minus x square
It's x
into
square
minus 12.
enumerate 2x and into x.
Correct?
Yes, sir.
So 2 and 2 will get cancelled. I will be equal to root of a square minus x square into x minus of minus will be plus. Actually, I'll leave that minus as it is. I don't want to disturb it because this will be minus x square. I have minus x square here. So I will add a, I will subtract divided by root of a square minus x square dx. Minus integral of, this will be root of a square minus x square plus a square into integral of dx divided by root of a square minus x square. Correct?
Yes.
This whole thing will be what? This will be I into I, this will be 2i. So 2i is equal to x into root of a square minus x square plus a square into 1 by root of a square minus x square is sine inverse of x by a plus c. Bring this 2 this side. Here it will be 2, here it will be 2. This is the answer. X by 2 into root of a square minus x square plus a square by 2 into sine inverse of x divided by a plus c is going to be the final answer. So copy it. Right. Now, with this knowledge, I'm going to explain you certain problem. Exercise you are going to solve. I'm not going to do anything. And reach out to me if you have any doubts. So integral of root of x square plus 2x plus 5 times dx. Okay. If this is the scenario, I'm going to make this as a perfect square. Root of, how to make it a perfect square? X plus 1 the whole square plus 5 minus 1 dx. This will become root of x plus 1 the whole square plus 4 dx. Correct? So this is of which form? Root of x square plus x square. So what is the answer? x by 2, that is x plus 1 by 2, plus a square by 2, that is 4 by 2, log of x plus root of x square plus 2x plus 5 plus c. Did you understand what I did? Did everyone understand how I applied the formula?
Yes, sir.
Yes, sir.
Very good. So please make a note. Right. How to do the next one? Integral of root of 3 minus 2x minus x square dx. Root of, I'll take the minus sign outside. It will be x square plus 2x minus 3 times dx. So integral of root of minus of x plus 1 the whole square minus 3 minus 1. So this will be root of 4 minus of x plus 1 the whole square times dx. Correct? Understood? So this
Yes,
is
sir.
the form a square minus x square, the last formula that we saw. I is equal to, what is it? X into root of a square minus x square. So x is x plus 1 into root of x square minus a square is nothing but the question. 3 minus 2x minus x square plus a square divided by 2. A square is 4 divided by 2 is 2. 2 into sine inverse of x plus 1 divided by 2 plus c. Right? One more problem. So we used two formulae. Right? You have only 11 problems, which are all already of same type. Right? So other problems, I assume you guys can solve it, right? Each problem 3 minutes.
Yes,
You
sir.
should do less than 35 minutes. So make practice it accordingly. So we are done with the concept of 7.7. Now we'll go to the next concept of definite integral. Okay. So till now, whatever we did was based on indefinite integral. Now we are going to the concept of definite integral. In definite integral, you are sure of the limits, right? So when you're sure of the limits, it is something like this. So this part is actually not there. I just checked the syllabus also. This is not there. This was not there last year also. This is called as the limit of a sum. Means you will find the definite integrals using the limits concept, which is from your 11th standard. Fortunately, it is not there. Okay. Now we are going to see the fundamental theorem of calculus, which speaks about the main application of why we do definite integrals. Like I always ask this question, right? You know what is differentiation? If I ask you why do you differentiate, what will your answer be? It is to find the slope of a tangent at a particular point, right? You're going to find the slope of a tangent at a particular point. Similarly, why do you integrate things? Integration is done to find area made by the curve, to find the area made by the curve with the independent axis. So what I'm trying to say is the integrate means I'm talking about definite integration. So definite means integral of a to b f of x dx is going to give you area made by f of x with respect to x-axis, right? How I found with respect to x-axis? Because f of x is the curve, x-axis is the one which is there within the differential coefficient. Within the x-axis, between the points A and B, which lie on x-axis. You're able to understand what I'm trying to say? So if somebody, so this is what is applications of integrals, which we'll be doing the next chapter. But before we do that chapter, since we need to get accustomed to the tool of using definite integrals, we'll be doing some problems, the basic problems here. So the next chapter, what you're supposed to do is you're supposed to frame the equation and then you're supposed to do the definite integrals. So for that reason, you need to ensure that you're mastering this particular chapter. Okay. So I'll tell you what it is. So I'll directly explain with the problem itself. If the question is integral of x square dx, what will you say the answer is? It is x cubed by 3 plus c. This is a known factor. But to the same integral of x square dx, if I add limit 2 to 3, then what is it going to be? This will be equal to, you will write x cubed by 3, that is the antiderivative you need to write. You need to put a square bracket like this. Write 2 at the bottom right corner and 3 at the top right corner. After this, see, this is called as upper limit and this is called as the lower limit. So you have to substitute the upper limit in the place of the independent variable. So when I substitute the upper limit, I get 3 cubed by 3 minus. You need to substitute. So you need to always put a minus. Upper limit minus the lower limit is 2 cubed divided by 3. So 3 cubed by 3 is 27 by 3, which is going to give us 9. 9 minus 8 by 3. So it becomes 17 minus 8. 17 minus 8 is 17. 27 minus 8 is 19 divided by 3. Okay. So the meaning of this 19 by 3 is, let me explain this clearly. Listen to this. So what did I say definite integrals is? It is the area made by the curve. It is area made by the curve with the independent axis. Here the independent axis is x. And 2 and 3 are the lower limit and upper limit of x. Am I clear with this? Now, the meaning of this 19 by 3 is, if I take a graph sheet and if I plot the graph of x square, what do I get? I'll get a curve like this.
Yes, sir.
Right. So 2 is somewhere over here, 3 is somewhere over here, 2 is here, 3 is here. If I find this area comes out to be 19 by 3 square units. That is the meaning. That is the meaning of area made by this curve with the x-axis, something like this. Am I clear with this?
Yes, sir. It's clear.
Right. So this is what you're supposed to do. Okay. Next. Shall I proceed to the next problem?
Yes, sir.
Okay. Listen. This is there, no? Integral of 4 to 9. Integral of 4 to 9 root x divided by 30 minus x power 3 by 2 the whole square times dx. Okay. So it is something like this. If I need to get a root x in the denominator, then on differentiating which function are we going to get root x? Root x is x power half. So what is the function? What is the basic function that I need to differentiate to get this x power half? That you know by integrating it. When you integrate x power half, what is that you're going to get? 2 by 3 into x power 3 by 2. Yes or no? 2 by 3 into x power 3 by 2. So that tells you that what I told you in the beginning of the chapter, right? You need to eliminate the denominator. For that, I will take 30 minus x power 3 by 2 as t. If I do that, I get minus 3 by 2 into x power half into dx as dt. So x power half dx will be equal to minus 2 by 3 times dt. Okay, so when you're doing the substitution, right, as of now, don't touch the limits, because when you're doing the substitution, you need to change the limit of x to t. That I'll teach later. As of now, what you do is first do the indefinite integration, find the value, and then substitute the limits for this exercise. Okay, so this is integral of minus 2 by 3 dt divided by t square. Correct? Minus 2 by 3 dt divided by t square. So minus 2 by 3, if I take outside, integral of dt by t square is actually minus 1 by t. So the final answer will come out as plus 2 by 3 t. Right? So plus 2 by 3 t is nothing but 2 divided by 3 into, sorry, 2 by 3 into t is how much? 30 minus x power 3 by 2. Right. Now you substitute the limit. What are the limits you're supposed to substitute? 4 and 9. Now substitute the limit and see. 2 by 3 will come out. 1 by 30 minus 9 power 3 by 2 is how much? 9 power half is 3. 3 power 3 is 27. Minus 1 divided by 30 minus, substitute the lower limit. 30 minus 4 power half is 2. 2 power 3 is 8. Right. So 2 by 3 into 1 divided by 3 minus 1 divided by 22. So 2 by 3 into 19 minus 3 divided by 66. This is going to be 33. So 19 minus 3 is 16 divided by 99. 16 only, no? 22 minus 3. Did I make any mistake? The answer is 19 by 30. So 2 by 3 into 1 by 3 minus?
Yes, sir. 22 minus 3.
20. I calculated 22 minus 3 in mind, and I wrote 19 minus 3. 22 minus 3 is 19, right? So 19 divided by 99. Right? So I hope you can solve the other problems as well. See, for example, if this problem, so what you're supposed to do is basically, you're going to follow the same process of indefinite integration, and at the end, whatever function you're getting, right, you need to substitute the upper limit minus lower limit. That is the only practice you need to do. So in this exercise, you can cover all the concepts that you have learned till now in indefinite integrals. Okay, don't worry, 7.7 has nothing to do with this. It is a completely independent topic, limit as a sum. So whatever you have learned till now is more than sufficient to solve this exercise. So the expectation for me in this week is you need to complete 7.6 and 7.8. And this has to be uploaded in the app. I'll upload it. I'll give an assignment task. Ensure you're uploading all your answers here by completing it. Sorry, not 7.8. I think I made a mistake. 7.7 and 7.9. Okay, once this is over, Next class, I'll teach you how to do the definite integrals by substitution. And the class next to it, that is on the next Tuesday, we'll do some basic properties of integrals, which is very, very, very important. So once that's over, this chapter is done. Okay. So any other doubt from today's class?
No doubt, sir.
No, sir.
I think we are good to wind up. Okay. These two exercises you complete. That's it from my side. Can leave,
Thank
guys.
you, sir.
Thank you, sir.